Alright, in this video we're going to introduce limits and algebraic techniques to working with limits. So the graphs of f of x is x squared minus 6x minus 7 over x minus 7 and g of x equals x plus 1 are very similar, but they're not the same. So if you look at the two graphs that we have here, on the left is the graph of f of x, the rational function, and on the right is the graph of g of x. Now, if you were to divide x squared minus 6x minus 7 by x minus 7, you would get x plus 1 as your answer. However, the function is not defined at x equals 7. So we do have a hole in the graph there because we have a common factor of x minus 7 in the numerator and x minus 7 in the denominator. So this factors as x minus 7 times x plus 1, and the x minus 7's divide out and cancel out. So because we have this hole in the graph, even though they appear to be the same, and most graphing calculators won't graph this hole in the graph outright, they're actually not the same equation. So in this video, we're going to look at finding limits via factoring, which can speed things up for quite a few of the problems that we've looked at in the past already. So some limits that can't be evaluated directly can be evaluated after you're canceling out or dividing out some common factors. For instance, the x minus 7 times x plus 1 over x minus 7, how f of x factored, you have some common factors of x minus 7 that cancel out. And when you have those common factors that cancel out, and you can then evaluate the limit, that's called removable discontinuity. So we'll talk about continuous functions and continuous at a point in a future video. So example 1, evaluate the limit as x approaches negative 3 of x squared plus 4x plus 3 over x plus 3. And if we evaluate this by plugging in negative 3 directly, we're going to get a 0 in the denominator, which is no good. However, the numerator, x squared plus 4x plus 3, that factors as x plus 3 times x plus 1. So we have the limit as x approaches negative 3 of x plus 3 times x plus 1 over x plus 3. And notice we have these common factors of x plus 3's. They'll cancel out and divide out to leave 1's in their places. So our limit becomes the limit as x approaches negative 3 of x plus 1. Now if we plug in negative 3 for x, we don't get any problems in return. So negative 3 plus 1 is negative 2. And if we look at a table of values for this example, plugging in numbers that are really close to negative 3 in for x, our outputs are going to get closer and closer to negative 2. Likewise, if we look at the graph of this function, there's a hole in the graph at x equals negative 3. The y-coordinate of that hole in the graph is negative 2, which happens to be the limit. Part B, we have limit as x approaches negative 2 of x plus 2 over x squared plus 7x plus 10. And if we plug in a negative 2 directly, we're going to get 0 over 0, which is no good. But our denominator is going to factor as x plus 2 times x plus 5. So noticing the x plus 2 in the numerator and the x plus 2 factor in the denominator, those are going to cancel out or divide out and leave 1's in their places. Now remember, there is a 1 in this numerator after it's been canceled out, so our expression simplifies as the limit as x approaches negative 2 of 1 over x plus 5, and then plugging in a negative 2 for x, we have 1 over negative 2 plus 5 is 1/3. Alright, so that does it for this first video. I'll see you in the next one.